Okay, so we're going to finish 2A and we're going to talk about composition and then the domain and range of compositions. So composition of functions is putting a function inside another function. That's what that is. So the notation, this is an open circle here. So that's saying f of g of x. It also can be written like this, which I think is a little bit easier because then you can see, okay, the g of x function is going into the f of x function. When we talk about domain and range of compositions, your domain is the domain of the inside function and then with respect to this outside function. So we'll talk about how to find it here in just a minute. And then your range is always based on what your domain is. Range isn't as important for us to learn as the domain. Okay, so we're going to look at an example. So we want to find f of g of x and then state the domain and range. So if I have f of g of x, that means g of x is the inside function. So g of x is what I'm plugging into f of x. So g of x goes into f of x, and it goes in for x. Okay. I have to do domain and range next. So before you simplify, you have to do domain and range. Because your domain and range is the domain and range of the composition. So not what the composition simplifies to, just what the composition is. So you're taking into account both functions here. So I'm going to put that as a note. So you must do domain and range after you plug in, but before you simplify. Okay, so let's talk about domain and range. So I see a radical here. So remember, whenever you have a radical, you take what's underneath and set it greater than or equal to 0. The radicals affect your domain. So that means that what's underneath is x squared minus 2 plus 2 must be greater than or equal to 0. Okay, we're going to want to solve this for x. So that's x squared is greater than or equal to 0. Whenever you do quadratics with inequalities, it's like doing absolute value with inequalities. So just as a side note, if you have x squared is greater than or equal to 4, okay, you're thinking about square rooting, and then you also think about plus or minus. But for the negative, like absolute value, the inequality has to switch. So you'd have x is greater than or equal to 2, or x is less than or equal to negative 2. That's how you would solve it if it were 4. With it being 0, well, there's not a positive negative 0. So you just get x is greater than or equal to 0, or x is less than or equal to 0, because there's not a positive negative 0. Okay, well, what's that telling us? So, yeah, so if you think about it being on a number line, x is greater than or equal to 0, x is less than or equal to 0. So it ends up the whole thing is shaded, so it's all reals, which we say negative infinity to positive infinity. Okay, now let's do range. So range is dependent on your domain. So range is your y values, which are the dependent variables. So I have to just understand my function. So I know I can plug in anything for x, but no matter what, when I take the square root, I'm going to get a positive number. So you're going to have a positive number underneath here because you're squaring. So no matter what, you're going to get a positive number underneath. So when you square root, you're going to get a positive number. So y will be anything from 0 to positive infinity. Y is going to be only positive because of that square root function. Range isn't as important as understanding the domain. Okay. All right, so we now go back and simplify this. So we're not done. We just have to stop in the middle to do domain and range, and then we want to simplify our composition. So f of g of x is the square root of x squared minus 2 plus 2. Okay, so that's the square root of x squared, which is x. So there is something significant with it that it simplifies to x, but we don't learn that really until chapter 4. What you just basically need to know is how to plug it in and then how to simplify. We also will talk about domain. So the reason why I have to do the domain and range before I simplify is because if I waited till now, what's my domain of x? what's a domain? This is a linear function, so what's the domain? What is the range? All real, but that's not the case. The composition is the range is 0 to positive infinity. So that's why I have to do that after I substitute, before I simplify. Okay, so let's go in reverse now. Let's now do g of f of x. Okay, so f of x, I'm just going to rewrite the functions here. Square root of x plus 2, and g of x is x squared minus 3. And I want to do g of f of x. So now f of x is the inside function. So that goes in for x and g of x. So I have square root of x plus 2 squared minus 2. Okay. Take a time out from simplifying and do domain and range. All right, so whenever you do domain, things that affect it are radicals and denominators, rationals. Okay, so do I have any radicals that you see? Right, eventually, yes. But I'm talking about the domain of the composition, so I have to take into account both functions. So I have to take into account that this is a radical right now. So there is a radical. So that tells me that x plus 2 has to be greater than or equal to 0. The squaring part doesn't matter. The minus 2 part doesn't matter for the domain. What matters is the radical. So x is greater than or equal to negative 2. Yes?
If the radical wasn't there, would it just be like a linear?
If the radical wasn't there, it would be quadratic because it would still have a square. Or do you mean after you
For the domain, would it just be off rails?
Yes. Yes. So your domain is negative 2 to positive infinity. Okay? I'm doing domain and range of the composition, not what it simplifies to. So I have to take into account both functions in the domain. Okay, so then for my range, so range is dependent on your domain. Since my domain has a minimum value of negative 2, then what I'm going to do is figure out, okay, if my minimum x is negative 2, what would be my minimum y? So I'm plugging negative 2 in for x here. So this is being plugged in right here. So that's 0. Square root of 0 is 0. 0 squared is 0. Oh, I'm sorry. This should say minus 2. Minus 2. Negative 2. So then my minimum range will be negative 2 as well. You will not be asked on your test to do range. You will have to know how to find domain, but you will not be asked to find the range. Okay. So now I can go back and simplify my composition. So now I know when I square a square root, I just get what's underneath. then 2 minus 2 is x. They're not always going to simplify to just x. The reason why these do is because they are inverses, and like I said, we'll talk more about that in chapter 4, but for now, you just have to know how to plug it in, how to find the domain. Okay? All right. Let's look at another one. All right, what it means by alternate definition is just the other way we can write this. Okay, so f of g of x, where you have g of x inside the f of x. Okay, I want to find f of g of x. So which one is the inside function? Okay. So this goes inside f. Okay, plug in and then take a pause to do domain. This one we just have to do domain, not the range as well. It wants us to find domain of G and the composition. Well, domain of G is part of the domain of the whole thing, because here's G of x. So let's at least just write the disclaimer for G of x. So for G of x, that's my disclaimer. X can't be 0. Okay, then for f of g of x, so we're worried about denominator. I don't have to see any radicals, okay? What I see are denominators. So I have this little denominator, so that's my x can't be 0, from this right here. And then I have another denominator. So then I have the whole denominator. So 3 over x minus 1 can't be 0. So if I solve that, 3 over x can't be 1. And then, no, you're right. So what x would give me 1? What would x have to be here? 3. So you know x can't be 3. If you were trying to solve this, if you can't quite see that, you couldn't quite figure out what that should be. So multiply both sides by x. Okay. So 3, and then 1 times x is x. 3 can't be x. Okay, so to write my domain, I need both of these. And that's the only issue, are the denominators. I don't have any radicals in this one, so I only have denominators to worry about. So if x can't be 0, x can't be 3. Let's look at that on a number line to help us write our intervals. So So if it can't be 0, there's a hole at 0. And then it can't be 3, there's a hole at 3. There's nothing else, so every other place will be shaded. Okay, my intervals need to be over what's shaded. So how many different shaded parts do I have? 3. So I'm going to have 3 intervals. So the first one is negative infinity up to 0 parentheses, because I have a hole there. And then I put a union, so I connect it then with 0 to 3 parentheses. Okay, that's the second one. And then what's my third one? Good. Parentheses 3 to positive infinity. So there's the domain. Now let's go back and simplify. So we need to simplify this because we don't leave a little fraction inside of a fraction. Okay, so what we need to do, I want to get rid of the little fraction. So what's the denominator in the little fraction? X. So I'm going to multiply top and bottom by x. And when I do that, so there's this minus here, which means that has invisible parentheses. When I do the denominator, I have to distribute the x. Okay, so on top, I have 2x over x times 3 over x minus x times 1. So that's me distributing the x. So then the x times 3 over x will cancel those, leaving me just with 3. And then x times 1, or negative x times 1 is negative x. Okay. Questions about that? So this is probably the hardest part of this section. Okay. The rest of it's not too bad. Your function operations, like you did on the warm-up, adding and subtracting. We're going to do some more of that, but with a graph. But the composition and then finding the domain, that's probably the hardest part of this section. So any questions about it that you have so far? Okay. So I'm going to graph f, g, and then f plus g. So I'm going to graph f of x, g of x, then I'll find the new function and graph that as well. What type of function is f of x? Linear. So we graph it using a slope and y-intercept. What's the slope? 1/2. What's the y-intercept? 0. So 0, 0. So on my graph, I start at 0, 0. And I go up 1 and right 2, or down 1 and left 2. These are not piecewise functions. They do not have domain restrictions. So I I should be graphing a whole one. It should go all the way through my graph. Arrows at the ends. Now, g of x. What type of function is g of x? Linear. What's the slope? The y-intercept? -1. Okay, let's graph that. So 0, -1. And up 1, right 1. Or down 1, left 1. Okay? Now we need to do f plus g. So f plus g of x. So you're going to do 1/2 x plus x minus 1. So 1/2 x plus x. Using the same fractions. Okay, so 3/2 x and then minus 1. So what type of function is this? Linear. My slope is 3/2. My y-intercept, 0, -1. So I'm going to go up 3 and right 2. Or down 3 and left 2. Okay, let's graph that. Okay, so if you're graphing these on the same graph, especially if you're just using a pencil or one color, you should label your lines. Okay, so this is not segment addition. You're not adding the red and the green to be like on top of each other and get this extra long line f plus g. They're all lines, so they're all continuous anyway, so you can't do that. What we're doing is we're taking the input values of f and g and figuring out those outputs, adding the outputs together to give me the new output of f plus g. So, for example, let's say I take the x value -2. Okay, so the y value for f is -1. The y value for g is -3. And so then -1 plus -3 is -4. So the y value for f plus g is -4. Okay, that's what we're doing. Is we're taking in any input, finding the outputs of f and g, and adding those together to give me my new output for f plus g. graph them, find f plus g, find your new function and just graph that. Find the new function and graph that. What we're going to do now is we're going to look at a graph and figure out what these new outputs would be. So it's kind of hard to see this. So the blue is p of x, and the red is q of x. So if I want to find f plus q of -4, that means I'm doing p of -4 plus q of -4. So p of -4, so that's where x is -4, the y value is 4. Q of -4, so now I'm doing the red. Here's -4 on x, so the y value is -4. So p plus q of -4 is 4 plus -4, which is 0. Let's do p times q of 1. So I'm doing p of 1 times q of 1. Okay, p of 1 is, okay, here's at 1, 2, 3, 4 times q of 1. So here's q of 1, 1, 2, -3. So 4 times -3 is -12. Okay. So I'll scroll back up so you can see the graph, but I want you guys to do E and H. So write down E and H, and then I'll scroll up so you can see the graph. Okay, so write this down. So here's the graph. Put your pencil or pen down when you're done, so I know you've had a chance. Okay. Mac, what do you have for E? On E? Okay. So finishing, okay? Corey, what do you have for H? Okay, -5. So you guys got H should be -5. Do we have E yet, Mac? Okay, 1/6. That's what you guys got. So keep these fractions. This is -5. Good. Okay, let's look at the compositions now. So let's look at K. So I'm going to do Q Q of P of 4. So what's my inside function? Okay, P of 4. And P is the blue one. So I need to find P of 4 first. So I go to my graph and I'm going to find P of 4. So 2, 3, 4, 1, 2. So P of 4 is 2. So now that output becomes the new input for Q. So that equals 2. So now I'm doing Q of 2. Okay. Q of 2. So here's 2. And now I'm doing Q. So 1, 2, 3, -4. Okay. So you guys do L. So write it down and then I'll scroll up so you can see the graph. So P of Q of -1. Alyssa, what'd you get? 4. That's the answer that I got. Everybody else get 4? Okay, good. All right, so we're going to practice one more of these. Okay, and then we will be done. Okay, so we're going to do another example like this. Scroll this up. Okay, so assume that all of these points are integers. So it's just a sketch, so it's obviously not a perfect scale here. Just assume they're all integers. So go ahead and do A and B. So again, put your pen or pencil down when you're done. Alright, let's finish this. Okay, Colton, what do you have for A? 1, I think I got -1. Do you see why it's -1? Maya, what do you have for this one? Oh, your pencil wasn't down. Okay, I'll let you finish.
No, he would do it.
Okay. Well, okay, walk me through it then. So what does this mean? F,
G goes in there.
okay. So, I want to do G of 1. So G of 1. So G of 1 would be 3. So this is 3. So then I'm going to do F of 3, which is 2.